Hey there, science enthusiasts! Today, I'm diving into the fascinating world of superconductivity and the Higgs field. Buckle up because this is going to be a mind-bending ride. Let's start with superconductivity. Imagine a world where electricity flows without resistance, a perfect conductor. That's exactly what superconductivity is. When certain materials are cooled to extremely low temperatures, they suddenly lose all electrical resistance. This means zero energy loss when current flows. Pretty cool, right? Now you might be wondering, why don't we use superconductors everywhere? Well, the catch is that most known superconductors only work at temperatures close to absolute zero. That's about minus 273 degrees Celsius. Not exactly practical for everyday use, but scientists are hard at work discovering materials that can superconduct at higher temperatures. Alright, let's switch gears and talk about the Higgs field. The Higgs field is like an invisible force field that exists everywhere in the universe. It's named after physicist Peter Higgs, one of the scientists who proposed its existence. But what does it do? The Higgs field gives particles their mass. Without it, particles would zip around at the speed of light and nothing would stick together to form atoms, stars, or even us. The key player here is the Higgs boson, often called the God particle. Discovered in 2012 by the Large Hadron Collider at CERN, this particle is the quantum manifestation of the Higgs field. When particles interact with the Higgs field, they acquire mass through the Higgs boson. Think of it like moving through a thick fog. The more particles interact with the field, the heavier they become. So how are superconductivity and the Higgs field connected? Well, they both involve breaking symmetries in fundamental physics. In superconductors, the symmetry breaking happens when electrons pair up and move in a coordinated fashion, creating a supercurrent. For the Higgs field, symmetry breaking gives rise to mass and the properties of elementary particles. Both phenomena are crucial in our quest to understand the universe. Superconductors could revolutionize technology with lossless power grids and ultra-fast computers. And the Higgs field helps us grasp why the universe is the way it is. So next time you flip a light switch or ponder the mysteries of the cosmos, remember the incredible science behind superconductivity and the Higgs field. Keep questioning, keep exploring, and stay curious. Until next time, thanks for watching.